Hello guys. So in this video, what we will do, we will basically discuss this problem from today's LeetCode's weekly contest. So it's actually a very good problem and a very basic concept of graph is required in this. So first, let's go through the problem statement. So basically what's given is there is one based binary matrix where 0 represents land and 1 represents water. So now you are given integers row and column, which are basically representing the number of row and column in the matrix. Now initially on day 0, the entire matrix is a land. So that means all cells have 0 as value. Okay, now however each day a new cell becomes flooded with water. Now you are given a one based 2D array cell where cells I equal to RICI represent that on the ith day the cell on the RIth column and CIth column, which are basically one based, will be covered with water. That is changed to 1. So you want to find the last day that it is possible to walk from the top to bottom by only walking on the land cells. You can start from any cell on the top row and end at any cell in the bottom row. You can only travel in the four cardinal directions, that is left, right, up and down. Okay, now you have to return the last day where it is possible to walk from top to the bottom by only walking on the land cells. Okay, so you are given this row and column, then number of cells. So these are cell on ith day is representing that on ith day which cell is going to be flooded. So here in this example, example number 1, initially all cells are 0 which are land. So you can start from any cell from top row and you can go on bottom row. So on the first day, cell number 1 in one based index, that is this first cell is going to be flooded. So you can still walk through second column. On third day, cell number 1 is going to be flooded. You can still walk. On the third day, cell number 1 comma 2 is going to be flooded. So on third day, there is no cell on the top row, which is land and from which you can walk to any cell in the bottom row using all land cells. So on third day you cannot walk. So second day was the last day where you could have completed your journey. So the answer for this is 2. Okay, so let's go through the constraint first, which will give us the idea of the time complexity. So if you see the number of row into column, which are total number of cell is basically 2 into 10 to the power 4. So we have to do it in less than order of n square. All right. So also it's given that cells are unique. Okay. So what's the basic idea? Basically, if at any condition, if at any stage on any day, you have to check if you can go through any cell on the top to any cell on the bottom, then you can do that using either DFS or BFS. Okay, so but that DFS and BFS will take your row into column time complexity, which is approximately your this is maximum 2 into 10 to the power 4. So your cells dot length is given that it is also row into column time. These cells which are representing on which day this cell is going to be filled. So if you're going to iterate through these cells, and on every day you fill one cell with water and then you will check, and then on next day if you will keep do like that, then you have to, in worst case you have to travel all cells, and for every cell you have to apply DFS or BFS. So this is going to be, if I say row into column as n, so it is going to be order of n square. So we have to do it in less than that. So the basic idea is if you see, if on some particular day, on ith day, if you are able to walk from top to bottom on ith day, then you will be able to walk on all day with less than I, right? And if on some particular day you were not able to walk from top to bottom, then on any subsequent day, on any day from I greater than on any day greater than I, you won't be able to do that. So we can basically make use of binary search over here. So the least day is going to be day one, and the last day is going to be row into column. So what we can do, we can find the midday, and if this is the midday, we will fill all cells from 0 to mid, and then we'll apply the BFS or DFS. So the time complexity would reduce to the BFS, and DFS will take order of n's order of n. If we are saying this row into column equal to 1, then it is going to be order of n, and this cells binary search in our cell array will be log of n. So our complexity will reduce to n log n, which will work fine. Okay. Okay, so now let's go and see how we can code this problem. Okay, so let's code this solution. So I will initialize left as 1 and right as cells.size. Okay, so initially I'm marking answer or the answer as right, and we will iterate while left is less than equal to right. We will calculate the mid value, and on mid value we will check if it is possible to work from top right to sorry, top row to bottom row on this mth day. If it is possible, we will mark our answer as m, and now we will check uh, for from m plus 1 to right part. So we will make our left as m plus 1. And if it is not possible, that means it is not possible on any day above m. So we will check for the part where right is less than m. So we will check from left to m minus 1. Okay, and finally we will return our answer. So this can walk function will basically check if it is possible to go on mth day. Okay, so in this can walk function, we are getting the day for which we have to check, and we are getting these cells which have the cell for each day, that is on which day which cell is going to be flooded. Then this row and column are the basically sizes of our grid. Okay, so we are initializing this grid, this 2D vector with size row and column and all numbers as 0. Okay, now we are checking for day. Uh, so we will iterate, and we will mark from day equal to 1 to day equal to day. So basically from I equal to 0 to I day minus 1, we will mark all cells as 1. Basically this is representing that this grid is filled on this day. Okay, so we will initialize one VTT vector while iterating, so that while iterating we will mark the cells which we have already encountered as visited, so that we don't repeat. Okay, now we will take one variable flag and initialize it with false. Now we will go to every cell in first row, and whichever cell is 0, that means we can start our journey from that cell. We can, so either we can make use of BFS or DFS to do that. So here I am going to make use of DFS. So if that cell is 0 on the first row, then I'm going to start my DFS. In my DFS I am passing this V, which is our grid, 0 comma j is the cell from which we are going to start, and visited is our visited grid. Okay, so if the deface returns true, that is we were able to go till the top, sorry, from top to bottom row, then we will mark flag as true and break the loop, and finally we will return the flag value. So if we couldn't go from top to bottom, then our flag will be false at the end, and that will be returned. Okay, now let's see how deface will work. So first we will check for the base condition if our index is out of bound, or the cell is visited, or the grid is already filled with water. Then in that case we will return false. Otherwise we will check if x is equal to v dot size minus 1, which is if we have reached in the bottom row. In that case we will return true. Otherwise we will mark that x comma y cell as visited, and then we will iterate in all four directions, that is top, right, bottom, and left. So from wherever we get uh, true, we will return true. Otherwise at the end we will return false. Okay, so the time complexity of this solution is basically NlogN, that is order of row into column log row into column. Okay, now let's test it. Okay, it got accepted. Well, all right, that's all for this video. Thank you for watching.